Good morning, everyone. Hope everyone's been having a good time, and thank you for coming to my talk today. I'm going to be talking about really how to call bullshit when a vendor tells you they have AI or machine learning, specifically around cybersecurity, because, well, you hear it with pretty much every single vendor. So, one of the reasons why you hear it so much these days is actually because AI and machine learning is super useful. It's not just used in cybersecurity, it's really used in any area that can use pattern recognition to make themselves more efficient. One of my favorite ones actually is in agriculture, because in this particular example, there was a company that took drones and high-resolution photos of crops in order to figure out where are the infections in their crop yields so that they can go spray pesticide or fungicide and go and take care of that small area far better than they would ever do just manually. But using that drone technology, they were able to accurately identify, hey, where are the areas of our crops that need more tending? In cybersecurity, it's super useful because of the fact that there are so many problems that are really big data problems that really lend itself well to this problem that we have, which is a shortage of human capacity, but also just limitations of where people's brains are at. So what is AI overall? When we talk about AI, what everyone is really talking about is that area on the right that's really machine learning. And the reason why we call it AI is, one, because it sounds cool, but what machine learning really is pattern recognition. And all of AI encompasses each of these different fields that you see here, and it's done in different ways. It can be applied to natural language processing, which is reading and writing of text and speech. It can apply to image recognition. And what I'm going to be talking about today is the specific area around file recognition, but we get into other areas as well. But the biggest reason why AI and machine learning is so prevalent these days is because we have more data than ever before, and it's harder to process that data, but we now have the computational technology to actually go and make this data into information. So the most important slide of this is really this slide. The other day when I was talking to a gentleman about what I was going to be talking about today, he actually thought of this really interesting example where if I wanted to be able to automatically identify vulnerabilities. And so I walked him through each of these stages, and this is where most organizations have AI today, which is really the introductory stage around machine learning. So when any company, including the one that I work for, when they start, they're really talking about starting with an assumption of an if-then statement. So this would really be phase one or generation one that you see in the first line. And this is where you're talking about taking the human steps and the human understanding of what am I trying to figure out and simply going and testing those assumptions. And when you hear a vendor say, we use linear regression, which sounds fancy because it has a lot of syllables, that is really, really basic stuff, which is really easily bypassable because all it's doing is making an if-then statement that crosses one line. So if you remember algebra and you remember the XY axis and you remember a line going through it, when you're on one side of the line, that basically means yes, and the other side of the line means no. And that is extremely easy to bypass, especially when it comes to a file, because files have so many characteristics or features, and that is typically, if it has X number of these, then it's going to be on this side of the line, but when it has Y number of those, it's going to be on that side of the line. But as we all know, when it comes to files, you don't always need every single piece in order to actually function. So that's where you start with basically the cloud prediction or cloud training, and that's where you're going to go. And you're probably just going to be sending things up to the cloud because all you're doing with the point of detection is it will send something up to figure something out at that standpoint. Level 2 is where you start to have a little bit more intelligence built into that. And what you're doing here is you're having an increased number of features that you've determined to really be important to determining what you actually need in order to predict, is this thing good or bad? And when you have that, you start to get into what's called supervised learning. And although this is going to still be easily bypassed, it does take longer. And what supervised learning is, it's taking all the information in your data set, and you are going to go and figure out what's actually important to this. But the thing is, you already know what you're looking for. So in that vulnerability case that we were talking about, we know what these CVEs are, we know how it's being done, and we know what to look for. And if we were to even automate all of this, it's still human readable, and we still understand it from a human perspective of what are we looking for. And what gets really, really interesting is when we start to go into level 3 and level 4, where you start to get into pattern recognition and really looking for those outliers. So what we did in level 1, going back to this, is we simply start with the data set. And that data set has to be massive, and it has to be accurately labeled. And this is because in machine learning, we have this term called garbage in equals garbage out. If you don't start with something that is accurate, at the end, your algorithm, which I'll talk about, is simply going to be inaccurate. It's going to throw off a ton of false positives, and that's because it didn't learn correctly. So the reason why, for instance, in the real world, we know what a chair looks like is because we have seen so many chairs in our life, and we've understood, all right, well, this typically has 4 legs, it has a seat, it may have a back. But we can also look at other things that have 4 legs and something that looks like you can sit on, and these might be a 4-legged animal, but we know that that's not a chair because we've seen the difference enough times. But if you were to feed that into your labeling and just say everything with 4 legs and some kind of a horizontal plane equals chair, you're going to get a lot of bad results when you go and look at that from an image recognition standpoint. So again, that's where you have to start to extract everything correctly and learn what are the really important features and what are the really precise features that go into the next training set. And when you start to get into that next level, at the end, that's where the machine is starting to use the neural network to then learn what are those patterns and start to suggest features or characteristics that we as the humans didn't even realize we needed to go look at those. And that's what really, really pumps up the accuracy. And that's where most companies really stall because they don't know how to figure out how to do that. And once you get to that last level, this is where you are doing what is called unsupervised learning. And very, very few companies are able to do this. And this is where you go into how to figure out what, again, are those patterns and be able to accurately identify something that the algorithm has never, ever seen before. And when someone says algorithm, all this essentially is a decision tree that was made to understand and predict something that it has never seen before. And the goal is to make this extremely accurate. And one of the areas that is really cool when you start to get into the data science realm of how does this work is really something called the k-means. And this is just one technique to find what are the features or characteristics in order to determine if all these little features that I'm looking at fall within this group or this cluster around a centroid. And in plain English, a centroid is just the cluster center. If it falls within that from a certain radius, literally a Euclidean distance, this means that this is going to contribute to the decision factor on whether this is the thing that you're looking at. And the reason why this is extremely difficult is because you need data scientists who really understand math and understand it really, really well and did well in school. And the hard part is finding people who really know how to do this, and not just in cybersecurity, but all those other industries that we saw before. So from this standpoint, this is where you go and figure out through trial and error, literally, what is that distance? Because if it is too large, you're going to get a ton of false positives because it's capturing too much. If you go too narrow, you're going to let too much bad stuff through because you're not keeping that radius large enough. So this becomes that art and a science that becomes, again, really, really hard, and it takes a lot of time and a really smart group of people who can figure out that information. And just for comparison, if you were to try and do this from a traditional malware analysis standpoint, because of the fact that, all right, well, how good is machine learning really? It's probably just doing what I can do manually just faster. And that's really where most companies are. So when you look at the practical malware analysis handbook, this is probably what you're going to learn. You can use a lot of free tools to do this, but this is still pretty difficult to do, even if you're good at it. And it'll take about 30 minutes on your best time. And you typically need to do something like, I need to detonate this first, or I just need to see, hey, is this hash already in a corpus that I can go to like VirusTotal? So that way, all right, cool. I know that it's already out there. I don't need to do anything about it except maybe do a reimage, do a quarantine, or whatever it is that I have in my tool set that I can already use. And then maybe if I can't figure that out, does it need to run? Do I run it in a sandbox and just see what it's doing? And at that point, I can also go and look at the code. I can look at the entropy, and I can see, well, does it look weird? Are there weird code caves in it? And I can, again, use all of these free tools to go do something like that. And again, at best, I can take one file and do this in about 30 minutes. But again, I may be hit with maybe 20 files that look weird in a given day, and that's my entire day if I do that. And I just literally don't have time to do that because I have other security things I need to be doing through the day, like patches, for instance, and anything else that comes to do that. And that's really where most AI tools are, is because of the fact that they're really just automating this, but they're not adding any additional value beyond this, because you as a human understand every single step of the process. What the machines are doing is going beyond this in order to understand, well, what are the patterns that you as a human don't even know to look for? But because I know to look for it, I'm able to more accurately determine what makes a file good or bad, because I have just been able to capture so much more data than you've been able to in the past, and even from a human understanding standpoint, and from a big data learning and data crunching standpoint. So as it relates to what my company does, we really apply it often to recognition of files and also scripts and memory-based attacks. But this is where we have our antivirus called Protect and Smart AV for the home edition. From a recognition of processes standpoint of, is this process good or bad? We have optics, that's our EDR. Recognition of people. So are you who you say you are based on how you type, how you move the mouse, and what applications you access? Again, everything is pattern recognition. And this is, again, really where machine learning is at today, because AI is really this idea of general intelligence, like what you and I have. And then we also have an entire services team that uses all of the tools that we have in order to do everything just much, much faster and more accurately than what a person could do. But more importantly, Black Hills says we do a good job. So yay, validation. This is written actually by Black Hills in a 5-part blog article back in March of 2017. And it was literally about how to bypass us. And you can go to Google right now. But what's awesome is they say that despite all that, you all do the best job of anyone else in the planet. And if you want to have something that's going to actually protect your systems against unknowns, use what Cylance has, because they actually do a very, very good job. But to their point, they are not a silver bullet. Anyone who claims that they're a silver bullet is trying to feed you something. And despite all that, they're still a very, very, very good bullet. So you should still get them if you're trying to protect your environment. So thank you very much. And if you want to learn more about machine learning or what that article was, that's going to be line 2 up there. And thank you very much, and I'm happy to answer any questions. And please take a picture and tweet this so that my marketing team can see that I did this. Yes, sir. Typically, no. So What AV was doing in the past was actually not machine learning, because what they were doing was literally just pattern recognition, or not pattern recognition, it was matching. So whenever you see Norton antivirus is out of date, what that's saying is maybe you need a patch for that particular agent like any other one. Maybe there's a feature update. But literally what's doing is it's adding definitions and adding signatures. So basically the fingerprints of files that it's looking for. But by definition of it being a list, that's out of date. So what it's looking for is any file that comes onto your machine, like let's say your personal computer, it's looking at the signature of that file and then matching it to its database. That is not even Gen 1. Most companies are struggling to really get to Gen 2. The company I work for, they were really the ones who pioneered using AI, and actually DARPA tried to do this and they couldn't do this because it takes a lot of money. I'll tell you that when the company first started, it took about 20% of AWS, and during the initial step, second step called vectorization, where you take characteristics and turn them into a number, that part is extremely computationally expensive, and it caused a brownout in AWS. So it's really hard to do, and I'll get to you in just a moment. So most companies, part of the problem is that they've been around so long that you can't just add machine learning as a feature. And that's really the hard part. You really have to start from ground zero in order to get to a really true machine learning product. And so that's why most companies who say they have machine learning can only get to Gen 1 and Gen 2. And they really started getting on the bandwagon, I would say, about 3 years ago. And honestly, it takes about a year just to sort through your data and label it correctly. And it takes about another year to really produce something in beta. And that's why, if you went to RSA about a year ago, that's why you start seeing a lot more around machine learning. So that's where most are today. You, sir. Sure. So the first question that I would ask is, can you tell me more about how you got your data set? That is step one. And if they're not willing to tell you that, that means that they do not have a team that is actually trying to filter out the garbage. So step one. Step two is, do you have clustering algorithms? If they give you a blank stare, they don't know what they're doing. Because the clustering part is, again, finding those groups. And there are many, many different clustering algorithms that have different pros and cons in order to figure out what do we care about. And just starting with those two questions, if neither of them are willing to answer those or give you a blank stare or won't even try and get someone to answer that for you, I would say they're really not doing something that is really next gen. Any other questions? Sure. So this is kind of a tricky part because the answer is yes and no. Because, so for instance, there was a researcher who created essentially a Gen 5 algorithm that learned how to beat Super Mario. And for a long time, they didn't understand how it figured it out. So there was some just trust, like, all right, well, it figured it out. And it'll take time to go and basically understand what did it learn in order to figure it out? Because when you look at the neural network and you look at all the pathways, there's millions of permutations and combinations that it took to figure that out. So it takes a lot of time to go and understand that. So that's why part of it is just, all right, I trust that you did it because it works, because when you throw it an entirely new set of data and it has 99x% accuracy, you're like, all right, well, it did. It takes a lot longer to figure out how did it figure out and why. Yeah, it's kind of weird to wrap your brain around, like, how's this machine doing it when I don't even understand it? Cool. Well, thank you all very much.